All right, guys, this is the 2016 BC exam. This is question number 4. And you're given a derivative, and you're asked to do a bunch of stuff with it. And before I get started, throughout this question, it says that, like, let y equal f of x be a particular solution, or let y equals h of x be a particular solution. When that happens, it's saying that this is the derivative of those particular solutions. So just keep that in mind. Okay, part A, it just says to find the second derivative in terms of x and y. So here's your first derivative. All right, when you're deriving it again, it's going to happen implicitly. So you got to have the y prime happening right there, right? So 2x minus 1/2 y prime. I've said so many times, the first derivative is always inside the second derivative. So you're simply replacing y prime with what it is, and then clean it up. All right, part B, it says let y equals f of x be the particular solution that passes through the point -2, 8. And then it says to talk about if f has a relative min-max or neither and to justify. Okay, so again, if y equals f of x is the particular solution, well, that's the derivative of f of x. Okay, so if I were to plug -2, 8 into the derivative, well, I get 4 minus 4, which is equal to 0. So we know the slope is 0 there. We just got to figure out if it's a min-max or neither. I'm going to choose the second derivative test because I just figured out what it was. Okay, so if I evaluate the second derivative at -2 and 8, I get out 0. So that means that it's a neither. Okay, if I'd gotten a positive out, it would indicate that was a minimum. And if I'd gotten a negative out, it would have indicated a maximum. But since it's a 0, it means neither. All right, part C, it says, let y equals g of x be the particular solution to the differential equation with g of -1 equals 2. And then find the limit as x approaches -1 of that foolishness, and then show the work that leads to your answer. Okay, well, you know that g of -1 is equal to 2. So if you plug in straight in, you get 0 over 0, which you know is indeterminate. So I'm going to L'Hopital it. Okay, if I L'Hopital the top, then you end up with g prime. If I derive the top, you get g prime. If you derive the bottom, you get 6 times x plus 1. Okay, again, I'm plugging in the coordinate -1, 2. Okay, so g prime of -1. Well, g prime of -1, well, again, that is g prime. So I'm plugging -1 and 2 into here. Okay, and I get 0 out. And I'm plugging -1 into here, and I get 0 out. So again, I have indeterminate, which means you got to L'Hopital it again. So g double prime of x over now just 6, okay? And again, you have your second derivative. It's right here. Okay, so you're plugging -1 and 2 into that guy, and it's just over 6. Clean it up, and you get -1/3. And then part D, you're letting h of x be the particular solution, given that h of 0 is 2. And then use Euler's method starting at 0 with two steps of equal size to approximate h of 1. Okay, so there's my original. Okay, I'm going up by 0.5s. So it's the previous output plus the step size times the derivative evaluated at the previous x and y. So the previous x and y are 0 and 2, and again, that is the derivative. Okay, so plug and chug, there's 1.5. Okay, so now I'm here. So now this time, that's my previous x, and that's my previous y. Okay, so your previous y plus the step size times your derivative evaluated at your previous x and y. Okay, so again, I'm plugging 0.5 and 1.5 up into here. And then there's my arithmetic, and you end up getting 1.25.